Okay, so hi guys, now we're going to be doing some questions on the binomial theorem and expansion so that we can get a good grasp and see if we actually get the concept. So here's the first part of a question. I'll show you part B later because we need first part in order to do the second part. So this is an exam style question pulled exactly from one of the papers. So it's find the first three terms in the expansion of 4 minus x over 16 all to the power of 6, in ascending powers of x. Give each term in its simplest form. Okay, so essentially we need to simplify this expression using the binomial theorem, which, if you don't remember, just go back to the video on the binomial theorem that I had posted recently and go over it so that you know exactly what we're talking about. Okay, so let's just use our quick formula. So they're only asking for the first three terms. Notice how we don't need to do any more than that. That means that doing more than that's probably not going to be useful in the next part. So the first step is doing 6, choose 0. We start off with r, this term, as 0, and n over here as the power that's raised to, which in this case is 6, times 4 to the power of n, which is 6 in this case, times negative x to the power over 16 to the power of 0, which means it's just 1 in this case. Plus, then we increase r by 1, making it 6 choose 1 times 4 to the power of 5 times negative x over 16 to the power of 1. We're increasing this by 1, this term by 1. Plus, and here's our last term, 6 choose 2 times 4 to the power of 4 times negative x over 16 squared. Now notice that they said ascending powers of x. So what's important to recall is that when we have x on the, when we write anything in the form a plus b to the power of n, this term over here, if x is in the b side, then that means that we're doing ascending powers. If x is over here as term a, that means we're doing descending, because this decreases by 1 as you go down here, then you go down here. It keeps decreasing by 1, while this thing increases by 1 as you go down. So anyway, let's go back to the question itself. So we can evaluate 6 choose 0, which is just 1, because there's only one way of choosing nothing from 6 items. And then 4 to the power of 6, we can use our calculator to figure that out. 4 to the power of 6 is 4,096. So this is 4,096. And this here, next, a negative x to the power, or negative x over 16 to the power of 0, that's just 1, because anything to the power of 0 is just 1. So this term over here is just 4,096. Then we add it to, so now let's evaluate each of these units separately, because they do not come out to just 1. So 6 choose 1, we can put that in our calculator, that just gives us 6. So let's leave them in brackets for now so we can collect all the terms. Then 4 to the power of 5, that's 1,024. And then we're also multiplying it by negative x over 16. So we'll leave this as it is until the next line. Let's just go on to the next term. So 6 choose 2, that's equal to 15. Then 4 to the power of 4, that's 256. And then it's multiplied, it's to the power of negative x over 16 to the power of 2. That means that it's positive. It's not going to be negative, because anything squared becomes positive. So we're going to multiply it by x squared over, and then I think 16 squared is 256, yes. So it's 4,096 plus 6 times 1,024 is 6,144, but we have to divide it by 16, which gives us 384. But we also have to subtract it because there is a negative sign over here. So it's negative 384x plus 15 times 256 in this case. Well, we actually don't even have to do 15 times 256 and then divide by 256, because the 256's over here cancel out. So it's just plus 15x squared. What's important to also notice is that ascending means we're going up. So the power of x keeps increasing. Over here, you can see as x to the power of 0. This is x to the power of 1. And this is x squared. It keeps going up. That means that we're doing ascending. So we're doing it correctly. Which gives us our final answer, which is 4,096 minus 384x plus 15x squared. And we can go to part B now. Okay, so this is part B of the original question that we had. It reads, hence find the term independent of x in the expansion of 4 minus x over 16 all to the power of 6 times x minus 1 over x squared. So we need to first identify a few keywords and understand what they mean. So hence, this word means that we have to use our answer to part A to help us in this question. We just can't use our own method. So we have to know how part A is related, and we'll get to that soon. Next, we need to know what independent of x means. That's basically the term that does not have x in it. So for example, in our other thing where we did 4 minus x over 16 to the power of 6, 4096 was one of our terms, and that would be independent of x because it does not have it's not raised to any power of x. Now, the other curveball we have is that it's multiplied by this over here. Before, when we were doing it, it was just doing one binomial and elaborating on that. However, we also should notice that this is just squared, so it's pretty easy to evaluate every separate term. So, what we also need to realize is initially they only asked us to find 3 terms of this power. That means we probably don't need the 4th, 5th, 6th, and 7th terms of this expansion. So let's just rewrite the first 3 terms of this expansion right here. Okay, so we have 4096 minus 384x plus 15x squared. I'll just draw a dot, 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 showing that there are more terms, but we just really don't need them. And then let's expand this term over here using binomial theorem, or we can just use our intuition. So the first term will obviously be x squared because this is being squared first. We can use something called FOIL. If you don't remember that, go back to the quadratics video, which I will be posting soon because I haven't actually released it yet. But the way we can use FOIL is, if you want just a recap, we just write down the terms like this because this is how we expand them. Now, x times x is x squared, which we've got there. X times negative 1 over x is negative 1. Then then negative 1 over x times x over here is negative 1 as well. And then negative 1 over x times negative 1 over x is plus 1 over x squared. Essentially, FOIL means that we multiply the outside terms, then we multiply, first the outside terms, then multiply these 2 terms, then these 2, then these 2. You multiply every single thing by itself. Okay, so this is what we've got. We can simplify that a bit further to give us 4096 minus 384x plus 15x squared, dot, 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 times x squared minus 2 plus 1 over x squared. Great. Now we have everything we need to know to evaluate this. We need to find the term independent of x. The thing we need to know first is what 2 things when they multiply will give us something that doesn't have x in it. Well, right off the bat, we can see that 4096, 1 multiplied by negative 2, there's no x in there. So that's probably one term we'll need to know. So let's just collect those. 96 times negative 2. Now, what are some other things we can spot? We can spot these 2 terms here. When you multiply them, the x squared will be divided by each other to form 15 because they'll cancel out. They'll just go boop and cancel out. So we can probably add those in there too. Now let's just see, are there any more terms that we're missing out? Well, no, because if we multiply 4096 by x squared, we still get a term with x. 4096 times 1 over x squared will also give us something that has x. It'll just be x to the power of negative 2. We also have negative 384x, which won't actually be helpful in this case because multiplying it by anything over here will not eliminate the x. So this is pretty much our term. Let's just simplify it now. So 4096 times negative 2. That is negative 8192. And we're adding it to 15x squared times 1 over x squared, which is just canceling these 2 out, which will give us 15. And when we evaluate this, it gives us negative 8177. So we don't even need to expand this term completely, and multiply it completely by this. All we need to do is just use all we need to do is just analyze the things that are relevant, because going further on, it's not like it's going to make a difference. It's not like we can cancel out any further on. We just need to analyze what we have and then therefore simplify it to get our answer, which in this case is -8177. We didn't even need to expand the entire thing and go through each term independently. This is such a simplified way of doing it. So therefore, our answer to this is -8177. That's the term independent of x. And coming back to this, the hence thing, we used our expansion earlier in order to help solve the problem. We didn't do a completely different method. We just did what we had in part A and transferred it to part B. That's why when it says hence or otherwise, that's when you can go and do your own method. But in this case, it just says hence, so we have to do this method. So now let's move on to another problem. Okay, so here's another problem. It says find the coefficient of x squared in the expansion of x minus 3 over x times x plus 2 over x, all raised to the power of 5. And this is 5 marks. So what they're asking us to do is basically the same thing as the last question we did, except they want us to do it like as one question, and also we have to identify how many terms in this do we actually need, because this is a lot of terms. We do not need to write down all 6 of these terms when the question only asks us for the coefficient of x squared. So it's our job to identify which terms in this sequence actually will give us a desired answer. So before we do that, let's first look at this term here, because it's crucial to understanding how we get x squared. When we multiply something from this thing with this, we have to multiply by x, because x times x will give us an x squared term. So we need something from x over here. When we look at this, it's 3 over x, so we need to multiply it by something with x cubed, as x cubed times 1 over x will give us an x squared coefficient. So now that we've narrowed our reach, we can begin to evaluate this term using what we know. Oh, sorry, it drew it really bold. I'll just erase that. So x plus 2 over x, sorry, to the power of 5 is equal to x to the power of 5. We don't need this term, but it's still good to write down because we will need future terms. Plus 5 choose 1 times x to the power of 4, decrease it by 1, times 2 over x. We'll simplify it later. Plus 5 choose 2 times x to the power of 3 times 2 over x squared. And then we'll add one more term just for good measure. Obviously, if you look at the binomial expansion, I'm just raising this term by 1 more than the previous one as I go through each of these terms, and I'm decreasing this one by 1 as I go through each term. Well, we can simplify this to show x to the power of 5 plus, and then 5 choose 1 is just 5. 5 times 2 is 10, and then 10 times x to the power of 4 over x, which is just 10x cubed. And 10x cubed is something we will need, because remember, when multiplying by the negative 3 over x in the other term, that will give us an x squared coefficient. But let's just keep going for now. Plus, and then 5 choose 2 over here is just 10. 10 times 2 squared, in this case, is 40. And then 40 times x cubed over x squared is 40x, which is something we will also need to multiply by this x over here. And then we probably won't need the next term, judging by the fact it's decreasing by 2 each time. So we will get something that is a little bit out of the way. So what I mean by that is, I didn't make it really clear, but this is, oops, it's the eraser tool I just used. This is to the power of 5, this is to the power of 3, this is to the power of 1. The next one will probably be to the power of -1, which means we won't need it. So I'm just going to omit it from the actual thing, because 1 over x will not help us get x squared in any case. So yes, we were right. We did not need all of the terms of x plus 2 over x to the power of 5. So now let's write it out like we did last time. X to the power of 5 plus 10x cubed plus 40x dot dot dot, because there are still more terms, times x minus 3 over x. Now we need to identify the combinations that will get us the coefficient of x squared, and we had before. So x to the power of 5 will not do anything. 10x cubed, when multiplied with this term, will give us something. So let's do it on one side, 10x cubed times -3 over x. Then we add it to this one, 40x times x will also give us something. So 40x times x Let's simplify that down. That gives us negative 30x squared plus 40x squared, which gives us 10x squared. So the coefficient, they don't want the entire term, they want the coefficient. So that means that the coefficient is just 10. Our answer is 10 for this question. And it wasn't actually that hard. It's just the 5 marks were probably due to the fact that it was combined with the other question that we'd done, and also that we had to identify how many terms we'd actually need. They didn't tell us to do the first 3 terms. They just told us, find the coefficient. So let's move on to one last problem. Okay, so let's look at the last problem of the video. So it's in the expansion of 1 plus x over 2 all to the power of n. The coefficient of x to the power of 4 is half the coefficient of x to the power of 6. Find the value of the positive constant n. So if you want to attempt this, pause the video here. But if not, let's go through it together. So first of all, notice how they want us to find the value of n. So that means that immediately we're going to be using a lot of combinations. And secondly, if you think about it, in our binomial expansion, we always have things in the form of n to the power n to the r, n choose r. And r always increases by 1, but we also cannot evaluate this if we don't know what n and r are. That's why we need to use the combinations formula, which is really important in this case. The combinations formula, if we don't remember, is n factorial over n minus r factorial. So we're going to be needing to use this because we right now have an unknown, which is n. So let's actually evaluate this now. So the coefficient of x to the power of 4. So that means we have to identify which value of r will give us which will give us the coefficient of 4. And in this case, it would be 4. So that means that n choose 4 times 1 to the power, well, it would be 1 to the power of n minus 4 if we use binomial theorem, but 1 to the power of anything gives us 1. So let's just leave it as 1. And then x over 2 to the power of 4. This will give us a coefficient of 4, which is equal to n choose 6, because that will identify the power of 6, times 1 times x over 2 to the power of 6. But notice that the coefficient of x to the power of 4 is half the coefficient of x to the power of 6. So if we double the coefficient of x to the power of 4, that will equate it to x to the power of 6's coefficient. All right, so let's simplify as much as we can. So this would give us 2 times x to the power of 4 over 16, because 2 to the power of 4, right? Times n choose 4, which is equal to n choose 6 times x to the power of 6 over 64, which is equal to x to the 4th over 8 times n choose 4, because the 2 and the 16 cancel out to give 8, which is equal to n choose 6 times x to the power of 6 over 64. What we can actually do, though, is we can remove these two values because they're not asking us for x to the power of 4 and x to the power of 6. They're asking us for the coefficients. So we can literally just replace it with 1. So it gives us 1 over 8 times n choose 4 is equal to 1 over 64 times n choose 6. And now let's multiply everything by 64 so we can get rid of these fractions, which will give us, so 64 over 8 is 8. So it's 8 times n choose 4, which is equal to n choose 6. Now you might be thinking, we're stuck at another roadblock. How do you evaluate n choose 4 and n choose 6? Well, that's where the formula comes in. Now we can replace this with this formula to give 8 times n factorial over n minus 4 factorial, because we're replacing r with 4 factorial. This way we can do the same thing here, n factorial over n minus 6 factorial, 6 factorial. And 6 factorial is essentially 6 times 5 times 4 times 3 times 2 times 1, which is, I'm just doing it on my calculator right now, 720. And 4 factorial is just 4 times 3 times 2 times 1, which is 24. So right now we have 8n factorial times n minus 4 factorial, and then I'll put 24 here. And this is equal to n factorial over n minus 6 factorial over 720. but I don't know why I put the bracket there. Let me just delete it. 720. Okay, now let's use some cross multiplication so we can get rid of the fractions entirely. That gives us, so 720 times 8 is 5760. 5760 times n factorial times n minus 6 factorial on one side, which is equal to, and then we multiply this way. So we multiplied this way already. Now something to multiply the other way. 24 times n factorial times n minus 4 factorial. Well, we can pretty much cancel out 5760 with 24 because 5760 is 240 times 24. So we have 240 times n factorial times n minus 6 factorial, which is equal to n factorial over n minus 4 factorial. And then we can get rid of the n factorials because they're on both sides of the equation. So we have 240 times n minus 6 factorial, which is equal to n minus 4 factorial. I never think that's a bad thing to have such long working like this, because actually it just allows you to clear it up and also makes it very clear to the examiner what you're doing. Okay, you might be thinking, we're at another roadblock here. How do we simplify n minus 6 factorial and n minus 4 factorial when we don't even know what n is? Well, the good thing is that we can actually do this. So n minus 4 factorial is actually bigger than n minus 6 factorial. We can prove this. Let's just take a number greater than 6 and 4. Let's say 7. So if we put 7 in as n, this becomes 1 factorial, which is just 1. And then if we put 7 in here, it's 7 minus 4 factorial, which is 3 factorial, which is 3 times 2, which is equal to 6. Therefore, this one is bigger. What does that mean? It means we can break this into something that cancels this out. How? Well, n minus 4 factorial is also equal to n minus 4 times n minus 5 times n minus 6 times n minus 7, so on and so forth, which can be seen as n minus 4 times n minus 5 times n minus 6 factorial, because it'll keep going on n minus 8, n minus 9, n minus 10, and that's how n minus 6 factorial does too. So we can actually cancel these out and replace this with this. Plug it in. So that means now we have 240 equals n minus 4 times n minus 5 times n minus 6 factorial, with this also being times by n minus 6 factorial. But these are canceled out. So now we have, 240 equals n minus 4 times n minus 5. Because factorial is going downwards, right? So if n is, let's say, 7, this will become 3 times 7 minus 5, which is 2, times 7 minus 6, which is 1, and then it'll stop like at this point. But like obviously n could be a really big number, and obviously it would keep going on like that. But it would still eliminate the n minus 6 factorial in any way. So now we have basically a quadratic because we expand it. It gives us n squared minus 5n minus, 4n plus 20, which can simplify down to 240 equals n squared minus 9n plus 20. We can drag the 240 to this side by subtracting 240 from both sides, so it's n squared minus 9n minus 220 is equal to 0. We could obviously use the quadratic formula, which is in another video if you haven't covered it yet, but we can just use our knowledge to also solve this. Because we know that 220 can be divided into 20 and 11, which is also going to give a product of 9. Well, it's going to subtract down to give negative 9, because n squared, because you times these two, n squared plus 11n minus 20n minus 220, so it works out. Okay, well, that's another story for another day. Let's focus on the actual problem. And we have n equals 20 and negative 11. You might be thinking, how do we know which solution is correct? Well, you can't have a negative value of n. You can't plug in a combination. You can't take 4 things, in this case, from negative 11 things. That's not possible. So what we have is our solution, which is 20. That means that n equals 20. How can we verify that? We can actually put this back in this equation. So let's actually use this simplified way of looking at it. So let's do the first side. 2 times 20 choose 4 gives us 9690. And then we divide it by 16 because 2 to the power 4 over here, which gives us 605.625. 605.625. And we compare it to this side here. So 20 choose 6. That's 38760. And we divide it by 2 to the power of 6, which is 64. And that gives us 605.625. So since they're the same, due to our equation, that means that n is actually 20, and we've got the right answer. So to conclude, the value for n equals 20. And although getting the power is probably the hardest thing you're going to get, always remember to use this formula and you can simplify it down. Especially with this section where you have to try and simplify these kind of things, use the logic over here that we talked about. And yeah, that's pretty much it for this video. Make sure to like, comment, and subscribe if you haven't already. And thanks so much for watching. If you have anything you'd like me to tackle, please let me know in the comments. I'll attach some worksheets, and I'll obviously attach timestamps, but you probably don't need them anymore now that you finished the video. But yeah, I'll attach worksheets in case you want to practice at binomial theorem. But overall, I think that's this unit covered. And yeah.